All right, so right now we're going to be looking at soil texture and productivity. So we know that productivity is how well essentially we can get energy fixed and in the ecosystem, which for these purposes, we're mostly thinking about primary productivity. So how well can plants grow within soil? And so the productivity of soil is going to depend on two main factors: the porosity and permeability of the soil. So porosity, how many little pores and air spaces it has, and how permeable it is for water and other things to get through it. And then the surface area of the soil particles, how much surface area is there? Because surface area allows nutrients and water and other things to stick to it. So if you have a lot of surface area to volume, ratio, then you're going to be able to have more water and nutrients sticking to the soil. So a smaller particle would have a greater surface area to volume ratio. And so these factors are going to result in different soil textures. And those soil textures, the way we classify soil, is based on how much sand, silt, and clay they have. And sand, silt, and clay have slightly different characteristics that allow them to have air spaces, allow them to let water through, but also allow them to hold the water and the nutrients, all based on this porosity and permeability and surface area of the particles. Okay, so let's look at clay. Clay is the smallest particles. They're really tiny. That means it's got a lot of surface area to volume ratio. It's really chemically reactive. It absorbs and holds water really well because of all that surface area that it has. And it also can hold nutrients really well with that surface area. So clay, it feels sticky when it's wet, right? When you get it all wet, and those particles are super fine and tiny. So clay holds water and nutrients very well. However, because the particles are so small, there's actually not a lot of air spaces. And so it doesn't have as much pockets of air that the organisms and the plant and places are going to need to carry out cell respiration, because they're going to need oxygen, right? And it can get really, really heavy as well. So there's some benefits to clay. It can lots of water and nutrient storage, but some of the downsides are that it doesn't have a lot of air spaces, not good aeration. And when it gets really heavy and sticky, it's really hard to work it. So it's hard if you're trying to create a farm with all that clay on it. Silt is a little bit larger particle, and it kind of feels slippery when it's wet. Silt is what you think about like on riverbeds. If you ever have your, with a flowing river, you can feel it. It's really fine. It's not quite sand. It's not quite clay. It's somewhere in between. The properties of silt, you're going to see, are kind of somewhere in between the clay and the sand. So everything with silt is kind of like medium. It can kind of hold water, and it can kind of hold nutrients, and it kind of has some, aeration, and it can kind of let the water drain. So it's kind of in between the two. Now, when we're looking at sand, because we're generally talking the most about sand and clay in this course, but if you're looking at sand, it's a much coarser particle than clay. It's really big. Now, it doesn't hold water well. Water will like the permeability of it, right? So water is not going to can infiltrate sand really well, but actually it infiltrates it too quickly because it's not holding on to that water very easily. So when you water it, it tends to just infiltrate, go down, but not really stick around. And so because it's got this less surface area to volume ratio for the particles, it's not going to hold nutrients as well. The water, leaches through it really quickly. But it has plenty of aeration, lots of, so it kind of keeps it a lighter soil, so the air can get through. And so the ease of working is, it's much easier because it's lighter and you can move it around really easily. But again, it's probably not going to hold the water and nutrients you need. All right. So if we were so these are the components of any soil. There's going to be some clay, there's going to be some sand, and there's going to be some silt. Okay. And then what you end up getting are all these different classifications of soil. And if you were to look at a soil that was 50, let's see, I think the one we're going to be looking at, a soil that is 30% clay, 30% sand, and 40% silt, like those combinations, you'd use this soil triangle to make some comparisons. So if we were looking for 30% clay, so clay goes in this direction. So we've got 30% clay. So it goes to the right on this line. And then if we had, let's see, there's our clay line. And then if we had 40% sand, 30% clay, 30% sand. So here's our 30% sand goes up and to the left. And then 40% silt, that goes down and to the left. It crosses through to what's called a clay loam. And the term loam is for a soil that has a pretty good balance between all three textures. So it's got clay and silt and sand. So you can see that's our clay loam. That would be our classification. You're going to be able to need to use this triangle to be able to classify soil, to classify soil. All right, now soil texture. And comparing this to productivity, most soils are going to be a combination of sand, silt, and clay, is what this should say. And loamy soil is the term to talk about an equal mixture of all three. So a soil that has a balance of the clay, the silt, and the sand, it can actually hold water pretty well, right? It can hold water pretty well. And that means it can hold nutrients pretty well, but it also kind of can drain so the soil doesn't get waterlogged. You notice the clay that we have around here, when it rains, it's just sticky and waterlogged. And that means there's not a lot of air spaces for the plants and the root to breathe. So you can get a lot of like rot and decay. And so a loamy soil is going to be a combination of those three. So it can hold water, but not too much. It lets it drain out some. That's the sand part that lets it drain out. The clay lets it hold the water. It can hold nutrients pretty well. And it's got plenty of air because the sand lets the water go through. So clay holds water and nutrients. The sand allows drainage for air spaces for roots to breathe. And then the silt kind of helps hold the two together. So this is why loamy soil tends to be the most productive, because it has all of these things that plants need. The workability, again, is another issue. Clay is really heavy, so you can't plow it. And you can't work the soil as often because it dries out really slowly, where lighter soils are more susceptible to drought and have poor nutrient holding capacity. So you kind of want to have that medium loamy texture to have the perfect productivity. This is a table comparing the three main textures, and then loam, what's kind of everything. So you can see loam is the ideal soil for productivity because the infiltration rate, the water holding capacity, the nutrient status, aeration, and ease of working, right? Where clay, the water cannot infiltrate it very easily, but it can hold the water really well, but it kind of sticks around, right? There's plenty of nutrients, terrible aeration, and it's hard to work because it's heavy. Whereas the sand the water can get through, it can infiltrate really easily, but the water holding capacity is very poor. It just leaves really quickly. There's not a lot of nutrients, but lots of aeration and easier to work. All right, well, hopefully this is helpful for you, and you're going to kind of create a similar table for this activity.